one is on reference angles, which will be a pretty important way to figure out specific values for trig functions that are not part of our special right triangles. We'll figure out a way that we can relate them to them. The definition for that you need to know is for any angle theta in standard position, it is the positive acute angle between the terminal side of theta and the x-axis. On this, if we look at on our coordinate plane, our x and our y-axes, let's say that I make that angle in there. So let's say that's angle theta. To get to the positive x-axis, we just need to go this way. So whatever theta is actually its own reference angle. And if you're in quadrant 1, that will happen. In quadrant 1, angles are their own reference angles because in quadrant 1, everything is going to be acute. If we move over here to quadrant 2, now we'd be dealing with an obtuse angle. To get it to be its reference angle, you drop down this way. So whatever this would be the reference angle. If we're in quadrant 3, we want to go up to the x-axis. So whatever that is would be your reference angle. And then if we go down to quadrant 4, we'd again want to go up. So whatever that is would be your reference angle. So you have it in standard position. So the initial side is the x-axis, the terminal side is wherever it is. You find the shortest distance to the x-axis. And it has to be the shortest distance because if you go the long way, it's not going to be an acute angle. Some examples with actual numbers I think will help clarify what this is. Name the reference angle for each of the following angles. So what I would suggest you do, and the homework will ask you to do this, graph each one first. So sketch an XY coordinate plane. And for 45 degrees, graph that. Since it's in quadrant 1, to get to the x-axis, you just go 45 degrees. So that's your answer. It's its own reference angle. On B, we're going to graph, again, and we're doing 150. So I'd start here. That takes me to 90, a little farther. So there's 150. To get to the x-axis, if I've already went 150, think halfway around is 180. 180 minus 150 would give me 30 degrees. So that's the reference angle. For C, same idea. Make a graph. Start here. We got 90, 180, 270, a little bit farther. There's my 300. Go to the x-axis, so I want to go up like this. All the way around is 360, so if I do 360 minus 300, that would tell me that's 60. So there's our reference. And then finally, 405, we can think about in two ways. We go here, there's 90, 180, 270, 360, 45 more, gets us there. So 45 degrees. What ends up being that A and D, 45 and 405, actually have the same reference angle. Where we'll use this is the reference angle theorem, and it states a trig function of an angle and its reference angle will differ at most in sign. So in other words, when you answer that, if you find the sine of an angle, and you find the sine of its reference angle, you're going to get the same number as your answer both times. If anything, the sign will differ, meaning maybe one of them's positive, the other one's negative, but the number won't change. So some examples of this, one of them that we did on the last slide, here's sine of 150. And just a reminder, the graph of 150, we had our xy, and then 150 ended up about here, and we said our reference angle was 30. If you evaluate the sine of 130, we should know from our special right triangle that that's a half. So the sine of 150 is also a half. That's in quadrant 1. That's in quadrant 2. The y is positive in both cases. So our answer is a positive half. But if I go to 210, and that I go 90, 180, 210. Now I'm in quadrant 3, and in quadrant 3, sine is negative. but the half doesn't change. With 330, we end up over here. I'm in quadrant 4, so I again get a negative. Just in case you need a little reminder on those signs, the first way that we defined our trig functions were the sine of theta is y over r, the cosine of theta is x over r, and the tangent is the combination of y over, I should say, x. In quadrant 1, x and y are both positive. So in quadrant 1, all three of our trig functions are positive. In quadrant 2, x is negative, y is positive. So sine would be positive, cosine would be negative, tangent would be negative. In quadrant 3, x and y are both negative, which means sine's negative and cosine's negative. And it would mean that since it's a negative over a negative, tangent would be positive. And in quadrant 4, we got plus then minus, which means negative for the sine, positive for the cosine, negative for the tangent. Some examples, we're going to find the exact value of the cosine of 495. And this is one that we cannot just plug into our calculator because that's going to give us a decimal. We want exact answers. So we'll probably graph it first. 495, we go 90, 180, 270, 360, 450, and then I have another 45 to go. So if I do 495 minus 360, I get 135. And that's kind of this top part here. That would be the 135. And then to go down to this, I need to get to 180. So if I do 180 minus 135, I get my reference angle is 45 degrees. So now we're really figuring out the cosine of 45 degrees, which we should have memorized by now as radical 2 over 2. If we need to, though, we can think about our 45, 45, 90. And we're doing cosine, so we could do adjacent to hypotenuse, so 1 over radical 2, and then when you rationalize it, you get that. Don't just assume that that's the answer to our problem, because we're answering the cosine of 495, and while it is going to have a radical 2 over 2, we have to think to ourselves, should it be positive or negative? We're answering cosine, and we terminated in quadrant 2. X is negative, which makes the cosine negative. And that's something you just have to think about before you finish each problem. Based on where your angle terminated, where are you? And then depending on which trig function you're finding in that quadrant, think about if it should be a plus or a minus. A couple more, same thing, sine of 225. So we would sketch our graph. We go 90, 180, 225. And if I do 225 minus 180, I get 45. So that's my reference. So I'm thinking sine of 45, which based off of our triangle is radical 2 over 2. And then think, okay, we're in quadrant 3. And in quadrant 3, sine is negative. So our actual answer, the sine of 225, is again negative radical 2 over 2. Next one, cosecant of 330. We could go with, instead of cosecant, let's think about its reciprocal. So let's think that this is going to be equal to 1 over the sine of 330, using the reciprocal identity. Then, think about your graph. We would go 90, 180, 270, 330. Take 360 minus 330, and we're left with 30. So this is the same thing as 1 over the sine of 30. And then instead of our 45, 45, 90, we might need to remember our 30, 60, 90. So we're doing sine, so opposite over hypotenuse. So this would equal 1 over a half, which would then become 2. And then final question, like we always got to do, should it be a positive or a negative 2? So we're dealing with cosecant, which will have the same sign as sine. We're in quadrant 4. The y is negative, so our answer should be negative 2. Going the other way, we're going to use our calculator to kind of aid us in this. Like we did last chapter, if I give you the value of the trig function, we can go backwards to figure out what angle would produce that. We do that by using our inverse keys. So we can do the sine of theta is negative 0.3090. We could do the sine inverse of negative 0.3090 to get an angle. So grab your calculator. Same up here. First thing, do not forget to check the mode. Make sure that it's set to degree. Once you've done that, you can type in sine inverse of negative 0.3090. And I got negative 17.99. So for our purposes, I'm okay with rounding that. We're going to go to 18 degrees. Our problem told us that it was supposed to be in quadrant 4. 18 is definitely not in quadrant 4. So we got to figure that out. So we could think about the fact that an angle and its reference angle could have the same value. So let's say we're in quadrant 4, we went 18 degrees down. So think about what would produce that. If you go all the way here, do 360 minus 18, and we'd get 342 degrees. A way that you can check yourself there is if you go back to your calculator, evaluate the sine of 342. And you should notice that what we just got to show up there, that negative 0.3090, is exactly what we started with. So as long as that matches up, you're good. If it's just a little bit off, you're probably okay. You remember the 18 wasn't exactly right. We had to round a little bit. So as long as it's only a minor change, you're okay. But I would recommend you check those every time. So another problem along a similar line. Find theta if the cosecant of theta is negative 1.7876 with theta in quadrant 3. So we're going to do these again like we did last chapter. If the cosecant of theta is that, then that would mean the sine of theta is equal to 1 over that. Remember, we have to do that because our calculator doesn't have keys for cosecant, or cotangent, or secant. Do the inverse. And we'll type it in exactly as we have it. So back to the calculator. Sine inverse 1 over negative 1.7876. Close it, hit enter. And I think we were okay with rounding that to about 34 degrees. Check the problem. It said we wanted it to be in quadrant 3. 34 degrees is in quadrant 1, so that's not what we want. So that's the reference angle. So think about your graph. We want to be in quadrant 3, so we would want to go down here, and that would be 34. So think about going this way. So we could do 180 plus 34 and get 214 degrees. And then to check it, we could do the sine of 214. I get that. and then do 1 divided by what we just came up with, and we end up pretty much with what the original problem had. Instead of 7876, I'm seeing 7882, but again, because our 214 had to be a little bit rounded, that's okay. Homework that I want you to work on for the rest of the blocks up there, page 113, 1 through 79, odds.